Hello dear students, welcome to your channel I Love Pharmacology. In today's session, let us learn about a very important concept related to general pharmacology. So can you able to identify the picture which has been shown on your screen? So do you think that this picture is example for agonist or competitive antagonist or non-competitive antagonist or none of the above? So please remember, in this diagram you can make a note of the x-axis and y-axis. X-axis represents the percent of maximal response, which tells us about the efficacy, whereas on the y-axis you can see the agonist dose, which tells us about the potency. So here you can see that there is a agonist which has been administered, agonist alone. So there is a response, you can see the response. So this is the potency and this is the efficacy. So what happens, there is a parallel rightward shift. You can see the response has been shifting toward the right side, but you can see that efficacy remains same, but the potency has decreased. So you need to give a increased dose of agonist. So here there is a response which you can able to make out at 0.1 dose, whereas here you need to increase the dose to more than 10% of the initial dose to get the similar response. So dose has increased but efficacy remains same. So this, where you will get this response? So whenever the agonist is given alone, so you are going to see the response. This is called as dose response curve. Along with agonist, if you are giving the competitive antagonist, if you are increasing the dose of the agonist along with the competitive antagonist, the increase in the dose of agonist will overcome the effect of the competitive antagonist. Thereby, it produces similar response to that of the agonist alone, but the dose will be increased. So this is the classical representation or a diagram which shows the effect of competitive antagonist. So in your exams or in the NEET, if you get this question, the answer will be competitive antagonist. So let us brief about what is agonist. So please remember, whenever the chemical substance attached to the receptor, it will going to produce a maximal response. So agonist will have high affinity. That means it has got high ability to bind to the receptor, as well as it has got high intrinsic activity. That means to say it produces some response. So whenever the agonist is attached to the receptor, it triggers the maximal response. It usually mimics the effect of the endogenous substances. So one such example is the methacholine, which is a cholinomimetic agent. Please remember, methacholine is a cholinomimetic agent which mimics the response which is produced by acetylcholine when it acts on the cholinergic receptor. So whereas what do you understand by competitive antagonist? So here the DRC, that is dose response curve, will shift towards right. There's a parallel rightward shift. Here you need to increase the dose to produce the same response that was seen when agonist is used alone. So here the efficacy will remain same but the potency will decrease. Whereas in case of non-competitive antagonist, the dose response curve will shift downwards. Here you can see that the efficacy will decrease. But potency will remain same. So this was about the class on the concept of competitive antagonist as well as the non-competitive antagonist. So please remember, if you get this diagram, so we need to choose an option of competitive antagonist. The correct answer is competitive antagonist. So if you find this video useful, please do subscribe to my channel I Love Pharmacology, and do not forget to share and hit the like button for more updates on pharmacology. Thank you.